Today we are starting Unit 4. I will get all of it on Schoology with updated quizzes and test days. I believe you will have a checkpoint on Friday. So that means a checkpoint, remember, is over this material that we do in class. I believe you will have one on Friday. Okay. Oh my goodness. Okay. All right. So we are starting rational expressions. Rational just means the letter is in the denominator, not in the numerator. Okay, so 1 over x is a rational because your letter is in the denominator. So a rational expression is the quotient, just means fraction, of two polynomials. A rational expression indicates division, and division by 0 is undefined. So I cannot define or divide anything by 0. So any value of a variable that makes a denominator 0 must be excluded. So all of that really wordy stuff just tells me my denominator cannot equal 0. So for every problem we do, you're going to have to tell me what the denominator or what the letter cannot be. Okay, so the first thing we're just going to figure out is how to determine which numbers make the rational undefined. So what we are going to do is we are going to set the denominator equal to 0. So undefined would just be when my denominator equals 0. You can do it two ways. You can simplify first, or you can just see, can I set it equal to 0? So example number 1, I could take out a GCF first if I wanted to, but I also know how to solve this. If I set 7x minus 28 equals 0, because it cannot equal 0. So if I move 28 to the other side, I have 7x equals 28. So x will equal 4. Now, what does that mean? That means if I were to plug in the number 4 here, what would happen? If I plug in 4, that would give me 28, and 28 minus 28 is, which we can't have. So what is the real answer? The real answer is x cannot equal 4. So x cannot equal 4, because if I plug the 4 in, my answer would be 0. Okay. So if I go to the second example over here, my denominator x squared plus 3x minus 10, I can't solve it, but I can factor it. So if I get some factors here, I will have x plus 5 and x minus 2. So I have to set both factors equal to 0. So x plus 5 equals 0, x minus 2 equals 0. And if I solve the first one, I get x equals -5. And if I solve the second one, I get x equals 2. But I don't want x to equal that. X cannot equal those two numbers, because if I plugged either one in, my denominator would be a 0. Questions so far? Okay, we're going to freeze. I want you to turn to the next page, and I'm going to give you 5 minutes. That's it. Only numbers 1 through 7 right here. I just want you to practice this real quick. So numbers 1 through 7, I'm going to pause the recording while I take attendance. So I want you to practice finding the rational expression is undefined. All that means is set denominator equal to 0 and find out what x cannot be. Okay, so while I take attendance, everybody should be working. So let's go to the second section. We are simplifying rational expressions, so they're not necessarily simplified for you. Okay, so a rational expression is simplified when the numerator and denominator have no common factors other than 1 or -1. So here are your steps, 3 steps to solve these types of problems. Number 1, you're going to factor the numerator and the denominator. Number 2, we're going to cancel out any common factors. They have to be exactly the same. You can only cancel top over bottom. You cannot cancel sideways ever. You can only cancel up and down. Okay? And go back to number 1 real quick. Let's talk about the different ways I can factor. Number 1, I can do a GCF. Number 2, you can make your eye chart where you have 2 parentheses. Or number 3, it could be a slide and divide problem. So everything from the previous unit is how we can factor. Okay, there also could be sum and difference of cube problems and difference of perfect squares. So everything from unit 3 can be on unit 4 now. And then we will write what is left. So let's do example 2a. So I need to factor or simplify the numerator. 5x plus 35, I can take a 5 out. And then what would be left would be x plus 7. And then my denominator would be a 20x. What can I do to the numbers 5 over 20? Simplify and it becomes 1 over 4. So how could I rewrite this problem? It would say x plus 7 over 4x. Now, here's the part you really have to practice. Comma, x cannot equal what? What can x not equal in my denominator? X cannot equal 0. So this is the part we just practiced. Okay. So number 2, looking at my numerator, I have x cubed plus x squared. What do they have in common? X squared. And if I factor that out, I'd be left with x plus 1. In my denominator, I have an x plus 1. So step number 2 says cancel common factors. If I have an x plus 1 in the numerator and an x plus 1 in the denominator, they can cancel out. So my final answer would be x squared, comma, be careful, what can x not equal? No. It cannot equal -1 because you have to use the original equation set equal to your denominator, or your denominator set equal to 0. So how can x not equal -1? Because x plus 1 equals 0, so x cannot equal -1. Okay. All right, so letter C, factor the top and get your 2 factors for me. And then factor the bottom. How do I know I can factor the bottom? It's a difference, and 25 is a perfect square. So that would be an x plus 5 and an x minus 5. So if you got confused, freeze really quick. If you got confused on letter B about where we got this part from, then go do that part first before you cancel anything out. So if I go do that part first right now, I know that x cannot equal what? What can x not equal in my denominator? -5 and +5. So I know right away it can't equal either one of those. Okay. So now in my problem, what factors can I cancel? What's exactly the same? X plus 5 and x plus 5 are exactly the same. So what is my simplified fraction? X plus 1 over x minus 5. Yes, if you write it with the x does not equal on top, that's fine. I won't take off for that. Okay. All right, let's go do letter D, and then you're just going to practice the rest of the class period. Letter D looks easy and tricky at the same time. So if I were to rewrite this, I have x minus 3 over -x plus 3. All I did is rearranged it. Okay. What factors does my -x plus 3? Can I take anything out of there to try to make it look like x minus 3? A -1. So x minus 3 is on top still. And if I take a -1 out of my denominator, then I would have x minus 3. And then what do I notice can happen to x minus 3's? They cancel. Be careful. What is still left in the numerator? A +1 is in the numerator. So 1 divided by -1 is just a -1. But what can x not equal? X cannot equal 3. Okay. So on the next page, you should have roughly 20 problems left to answer if you didn't finish all of the ones on top. This is all we are doing today, so you have plenty of time to practice. And then tomorrow it adds on to this. So if you can't do this, you've really got to start practicing it, because tomorrow we are moving on to multiplication and division.